In this video, we are going to learn about integer division. So before going into detail, we need to know the division of binary number by hand. So for that, we are going to start with an example. 27 divided by 13. We need to take the binary of 27 and 13. Binary of 27 is 1 and 13 is 1 1 0 1. So in order to take the division, 27 will be the dividend, 13 will be the divisor. So while dividing 1 similar to the decimal division only, you have to take digit by digit, you have to take whether it is divisible by 1101. So 1 means you want it is less than 1101, you won't be able to take 10. If you take also, it is less than 1101. If 1000, this is less than 1101, so you have to take this 5 digits 10001. So 1 1 1 0 1. Perform the subtraction operation. 0 0, so you have to take the carry 0 1. From here also 1 carry you have to take, here it becomes 1 1, so remaining 1 0 0. This will be the result you obtain after performing the subtraction. Now whether this is divisible by 1101, no, so you have to take 1 0 from here. Whether it is divisible, no, so place a 0 over here, and again you take 1 0 from the dividend. Now it is you can perform you can take this divisor to the below this part, so that a subtraction operation can be performed. 0 1, so carry you have to take, so from this 0 1 1 1 1, so we'll be getting 1 1 0 0. Here also everything 0. Again you have to check whether this is divisible by, no, this one is less, so you have to take 1 from here. This is also not divisible, 0. Again you have to take 0. Whether it is divisible, this one is larger than the this, that is this one you will be getting 8 plus 4 plus 2 12 14, and this is 13, so you can take 1 1 1 0 1, so take the carry 1 0. So this is the remainder, and this one is a quotient while performing the division. Okay, so in this method, how the division is being applied, it positions the divisor with respect to the dividend and performs a subtraction operation. If the remainder obtained is 0 or positive, a quotient bit of 1 is determined. Then the obtained remainder is extended by another bit of the dividend part. So another bit is taken from the dividend part. Again the divisor is repositioned to make the next subtraction. So if the remainder obtained is a negative one, which is very slow, which is very low when compared to the divisor, then a quotient bit of 0 is placed. The dividend is restored by adding back the divisor, and the divisor is restored by making another subtraction. So if a 0 is placed, you have to take the next bit from the dividend, perform the subtraction and check for the remainder. So this is the process performed while performing the integer division. Divisor is placed, perform the subtraction, or if the result obtained is remainder obtained is positive or 0, place 1 in the quotient bit, and if the remainder obtained is negative, you have to extend the bit from the dividend part, perform the subtraction by repositioning the divisor. So this will be continued till it reaches to the end of the dividend bit. The quotient you will be getting will be here and the remainder will be here. This circuit shows the arrangement for the binary division that we have performed earlier. Like similar to the multiplication operation, you are having A register, Q register, M register. A will be the accumulator, which is having n plus 1 bits when compared to the dividend. So dividend will be having n bits. A register will be having n plus 1 bits. Similarly, divisor will be stored in capital M register. This also will be having n plus 1 bit. Dividend will be stored in the Q register. Shift operation will be performed to the left, which will be using the registers A and Q, where the shift operation is performed. Quotient also will be set in this Q register. Initially it starts with storing the dividend part. After performing the division, quotient will be stored in the Q register. Remainder will be formed in the A register. In between the add or subtract operation, either to restore the value or perform the subtract operation, will be done by the n plus 1 bit adder, and this will be decided by the control sequencer. So control sequencer helps in shifting the registers, AQ register to the left, as well as quotient setting, and to perform the add or subtract operation. So this operations, it depends on the bit of the A register that we can discuss in detail by doing the next example. So A register, it helps in determining whether to shift the registers to the left, whether to perform add or subtract operation, etc. So n plus 1 bit adder, it performs the add or subtract operation, taking the A register value and the M register value. M will be having the divisor, A will be the accumulator value, and then it restores the value. Whether to be restored or not also, it will be decided by the operations performed in the control sequencer. So this is the circuit of the binary division. Next we can discuss the same circuit with the help of an example. The example will be performing restoring division process. It follows some algorithm. Take for example 11 by 3 division. So here we are going to initialize the registers QM, QMA. Also number of bits also we are going to initialize. So before that, you need to know the binary of 11 and 3. 11 binary is 1 0 1 1. 3 binary 0 1 1. Okay, so to make the bits same, we are making it as 0 0 1 1. So here the minimum number of bits that is used, n is equal to 4. N is equal to 4, that is the number of bits. Now you have to initialize, you know n is equal to 4, you need to know the M register value, A and Q. So from the diagram, you know that Q will be having n bits, and Q will be storing Q will be storing the dividend part. From the diagram, circuit diagram, you know Q will be having the dividend part. So here the dividend is 11. So Q will be having 1 0 1 1. A will be initialized to 0. So and it will be having n plus 1 bits. So 5 here 4 bits used to represent the dividend. So here it will be having n plus 5 bit. Similarly, in case of M also, M will be having the divisor, that is 0011, which will be represented using n plus 1 bit, that is 5 bits. 1 2 3. Now you have to perform the division operation. So with respect to the algorithm, first you have to perform the shift left operation of the registers A and Q. So shift left AQ register. Performing the shift left operation of the AQ register, you will be getting the result like left you have to shift 0 0 0 0. This one will be moved to here 1 0 1 1. This will be left unfilled. Okay, now next step you have to perform is you have to perform the subtraction operation. A is equal to A minus M. So A is equal to A minus M means that to this A register value you have to add the 2's complement of M. M will be having the divisor, 2's complement will be added with this A register value. So 2's complement of 0 0 0 1 1 is, you have to take the 1's complement plus 1. You will be getting the result as 1 1 0 1. So performing the addition of this 2's complement number, carry 1 1 1. Okay, now you have to check the bit. This bit you have to check. A of n bit you have to check. If this bit is equal to 1, this Q0 value, Q register bit, that is Q0 bit value will be set to 0. Okay, so if the nth bit of the A register is 1, here you have to place 0. So this can be made as 0 1 1. So setting the 0th bit of Q register as 0, that is the first step. Set Q0 to 0, or you can make it once again. If the bit is nth bit of A register is 1, you have to set the 0th bit of Q register to 0 and then perform the restore operation. So you are setting 0th bit of Q register. I am naming it as Q0 to 0 and perform the restore operation of A. Restore operation means before performing this operation, the value of A is this one. So you have to restore to the previous value, or what you have to do is you can add the divisor together to this resulting bit to get the result as 0 0 0 0 1 0 1 1 0. Okay, that is two operation you have to perform if the bit is 1. One is you have to set the Q0 bit as 0 and restore the value of A. Restore the value of A means before performing the subtraction operation, what is the value of A that you have to restore. And this can be obtained by adding the result with this divisor. That is adding what you will be getting 1, 0 carry 0. So you will be getting the result if you add the result with this divisor. Okay, now again you have to do the subtraction of this n bit. N is equal to n minus 1, which is equal to 3. N is equal to 3. Now this n bit n is not equal to 0, so perform the same step once till the n value reaches 0. So again perform the shift left operation. Shift left operation is 0 will be shifted here. 1, 1, 0. Okay. Now next what you have to do, perform the subtraction operation. Subtraction operation with the divisor this 0, 0, 0, 1. Subtraction operation means you have to add it with the 2's complement of the divisor. So you will be getting adding with the 2. So adding with the divisor, you will be getting the result like this. In this you will be getting a carry which can be neglected. Now again you will be checking the nth bit of the A register, and this is 0. So if the value is 0, you have to set the Q0 bit as 1. Okay, so this you can deal it with you can remember it with the help of a flow chart. So this is the algorithm that is used to perform the division operation, and that is restoring division operation, restoring method, using the restoring method. So you are setting the number of bits as n, accumulator value is set to 0, then divisor will be stored in M register, dividend will be stored to the Q register. And first operation is you are shifting to the left the AQ register, performing the subtraction of the divisor from the accumulator, and nth bit of accumulator is checked. If it is equal to 1, Q0 will be set to 0, restore the value of A. If it is equal to 0, Q0 bit will be set to 1, decrement the n value, n is equal to n minus 1, and you will be checking whether n is equal to 0. If it is equal to 0, then quotient will be in Q, remainder will be in A. If it is not equal to 0, perform the operation or the cycle repeatedly till the n value reaches to 0. This is the flowchart to be followed while performing the division operation using restoring method. So we can continue the example. So now the n value is equal to 2, and since the value of an bit is equal to 0, we just added 1 to the Q register. Q0 bit is 1. No restoring is being performed. So at the end of this cycle, A will be having 0, 1, 0, and Q register will be having 1, 0, 0, 1. N is in this cycle n will be equal to 2. So at the end of this cycle n will be equal to 2. A register value will be this one, and Q also will be this 1, 0, 0, 1. Now the next process is you have to decrement the value of n, that is n is equal to 1. N is equal to 1. It performs what you have to do, shift left the AQ register. While performing the shift operation, what is the result you will be getting? 0, 0, 1, 0. 1 will be coming here, 1. Remaining 0, 0, 1. This bit will be left as unfilled. Now the bit is 0. So what you have to do? You have to set the Q of 0 bit as 1. One step I left out, that is after performing the shift operation. From the flow chart, after performing the shift operation, what is the task to be done? A is equal to A minus M. Then only you will be checking the bit of the A register, whether it is 1 or 0. So in continuing the example, after performing the shift operation, you have to perform A is equal to A minus M. So adding it with the 2's complement of the divisor. So 2's complement of divisor is 11101. While adding it, you will be getting 0, carry 1, 1, 0, 0, 1. This carry will be neglected. Now here it remains the same, 0, 0, 1. So since the bit, now you have to check the nth bit of A register. Since it is equal to 0, the 0th bit of Q register will be set to 1. So setting the Q of 0 bit as 1, you will be getting the result like this. Now decrement the value of n, and now n is equal to 0, which means it reached to the end of the cycle. Quotient will be obtained in the Q register, and remainder will be obtained in the A register. So while we are dividing 11 by 3, what is the result obtained? 3 3s are 9. So quotient is 3, remainder is 2. So here also you got the remainder as 2 and quotient as 3. So this is how a restoring division is performed for the positive numbers.